Hey Kim Stars, welcome back. Today we're going to go on to grams per mole. We're going to actually use those molar masses, but first we must review percent composition. So we've already found the molar masses of potassium peroxide and silicon dioxide, so you shouldn't have to work too hard, but in each of these you're going to find the percent oxygen in potassium peroxide, and then what is the percent oxygen in silicon dioxide, and then you're going to answer a question: which substance has the greater percentage of oxygen by mass, potassium peroxide or silicon dioxide? All right, hit pause, solve this, see you down at 4.4. Okay, we've made it to 4.4. This is grams per mole, or grams to moles, sorry. You still need a calculator and a periodic table for this, so if you don't have that, hit pause, go grab it. So remember, across the top, this is on the right side of your page, we've got 4.4, this is grams to moles, and this is page 27. And we're actually going to work backwards too, we'll do moles to grams as well. But the title was a lot shorter this way. Okay, so what we've got, grams to moles, moles to grams, our equivalence statement. If you remember, back when we did conversions between like the English and the metric system, like when we converted inches to feet, feet to miles, miles to kilometers, those were equivalence statements. So they're showing two units that are equal to each other. That's not an R. There we go. Equal to each other. All right, so we're showing two units and how they are equal when we put them together. So what we have here is that 1 mole of any substance equals that molar mass. And remember, we said in a video a couple of ways back is that a mole is kind of an amount of substance, so we can talk about apples and apples. So remember, this mole is an amount of substance. All right, and it'll hopefully become more clear as we use it more and more. All right, so 1 mole, that's our equivalence statement. 1 mole equals the molar mass of that substance. So our steps, some pretty simple steps here. We find the molar mass of our substance, then we convert to what we're looking for. If we're going to grams, we multiply by molar mass. If we're going to moles, we divide by molar mass. But we're going to set it up in a T-chart so we can check that out. So we're going to use the two substances, water and iron 2 chlorate, that we've been using all along to kind of help us in our journey here. So if we look, our first one says how many grams. We're looking for grams of water. I like to circle what I'm looking for just so I know. And then I underline what I know, so what I'm starting with. So I'm going to start with 250 moles of water. So on my T-chart, I'm going to put 250.0 moles of H2O. All right. Awesome. Now, blow this up just a little bit. We're going to grams, so we multiply by the molar mass. And that's because if we look right here, this 18.02, what if we wrote it like this? Could we say 18.02 grams equals 1 mole? That's the same thing as what we wrote right here, right? So now we have our own little equivalence statement. And remember, we want to cancel things out by putting them on top and bottom. And so we have 1 mole of H2O has a molar mass of 18.02 grams. And notice how this works. If we look here, moles of H2O cancel. And so we're just going to take 250 times 18.02. So in our calculator, 250 times 18.02. Kind of doubt anybody wants to do that one in their head, but maybe you do. I don't know. And that's going to give us 4,505, and we're going to call that grams of H2O. Pretty simple, yes? All right, let's try another one, but with a smaller number. So this time we're still looking for grams of water. So we're going to be using that molar mass. We know we have 0.981 moles this time. So our setup of our T-chart is going to be very similar. 0.981 moles of H2O. And we're taking that to grams. So we're going to say 1 mole of H2O on bottom. And that's going to be equal to our molar mass up here, 18.02, that we just used. And remember, for each substance, this is going to be different. Right now, we're just using water, but when we do iron 2 chlorate in a couple of seconds, it'll be just a little bit different. So remember, solving a T-chart, we're just going to multiply across the top. So we're going to take 0.981, and then we're going to times it by 18.02, and divide by 1 if we wanted to, but we don't really need to. And we're going to let's just keep 1 decimal this time. So we're going to say 17.7 grams of H2O. Pretty simple to convert 2 grams from moles. So let's see if we can't reverse that using iron 2 chlorate. So rolling down, this time we're looking for moles of iron 2 chlorate, and we have grams, and we have our molar mass. And remember, if we rewrite it like this, 222.75 grams equals 1 mole. All right. So this time we're going to start with 794 grams. And remember, iron 2 chlorate, its symbol was like that. Make our little T-chart. Okay. Okay. And now we're going to, this time we have grams right here, so we need to put grams down here. So we're going to say 222.75 grams and 1 mole of iron 2 chlorate on top. And now that we've reversed this, so now we multiply 794 times 1, which is just 794, and then we're going to divide by 222.75. And our answer, let's keep 2 decimals, so we're going to say 3.56, and our label in this case is moles. All right? And this FeClO3 parentheses 2, you do not have to put the mole. You have to have, right? If you didn't have the mole, it would be counted wrong. But the FeCl3 parentheses 2, you do not have to put. Okay? So let's try this last one. If you want to work ahead of me and jump ahead, that's totally awesome. So we're looking for moles of iron 2 chlorate again. And we have 0.108 grams this time. So again, we're going to start with that 0.108. Start with what's given to us in the problem. And that's our iron 3 chlorate. Okay. And so we know that 222.75 grams is equal to 1 mole of iron 2 chlorate. So this is going to give me a pretty small number. Sorry, I almost wrote a 3 there, but didn't. So we're going to take, this time we're going to take 0.108 and divide by 222.75. Like I said, it's going to be a small one. Whoo, buddy. So we're going to say 0.000, 3 zeros, and then 485. 485. And remember, our label has to be at least moles. And if you want to put the iron 3 chlorate or iron 2 chlorate stuff on there, you're welcome to. Awesome. Okay. See you next time.